Hello, we're going to look at another exponential function, try to find, well, we will find its logarithmic function that is its inverse, and talk about the different parts of it and how they're related. Okay, so this time we're looking at a function f of x equals 2 to the power of x subtract 1 plus 3. So we've got two transformations here. Okay, so we've got two transformations. Let's go down to our chart. The exponential function, two transformations. We've got a horizontal translation of 1 unit to the right, and we have a vertical translation 3 units up. Okay, so those are the transformations compared to f of x equals 2 to the power of x as its base function. All right, so I just figured out some points on the graph here by plugging 0 into where x is and getting 3.5 or 7/2. So there's the y-intercept. Then the other points are 1, 4, 2, 5, 3, 7, 4, 11. Now remember, you could think of these points as being originally on 2 to the power of x, which y equals 2 to the power of x would have a y-intercept of 1. And then we're moving that graph over 1 unit and up 3 units, which brings it to 1, 4. Okay, notice that for the scale of this graph, each grid mark is 2 units. All right, so graphing the... well, let's talk about these down here, I guess, first. So the domain of this function is x is an element of R, all real numbers. The range, the smallest y value is almost 3, not quite 3, but 2.99, no, 3.0000000000001, for instance. Not quite 3, but almost a 3, and all the way to infinity. So y is greater than 3 is the range. Sorry about that, there's a helicopter going over top of us right now. And the asymptote is a horizontal asymptote. Horizontal asymptote. And the equation of that horizontal asymptote is y equals 3. All right, so now the inverse function that is related to this function is going to be again reflected in the line y equals x. Okay, so x's and y's all trade places. We'll have a corresponding point on the line 4, 1 on the new curve, 5, 2, 7, 3. And remember, this asymptote has nothing to do with the red graph right now. So yes, it does cross that asymptote. 11, 4 would be out here. Going the other way, 0, 2, 0, 7/2 would be 7/2, 0, so 3.5, 0. And then we would also have here coming halfway, and we will have 3.5. That's not quite 3.5 there, is it? That's the problem. 3.5 would be 3/4 of the way across here. Okay, and we're going to have a vertical asymptote this time. Remember, all things y becomes x, all things x becomes y. So this y equals 3 horizontal asymptote is actually going to become an x equals 3 vertical asymptote. Okay, so this curve does this. Okay, and this is our inverse function. All right, so let's look at this inverse function. The domain of this inverse function is anything bigger than 3. Okay, notice the range became the domain. The range of this function is y is an element of R. Notice again, the domain became the range here. The range became the domain. The horizontal asymptote on our exponential function, on our log function, becomes a vertical asymptote. And the equation of that is x equals 3. And the transformations, now we'll come back to that one in a second. Let's figure out what is the equation of this function. And remember, we can do that graphically. So we're starting with this, our original function. Replace the f of x with y. Okay, now we're going to inverse it. All y's become an x, all x's become a y. All right, now we need to isolate y. So in order to start doing that, we need to isolate the exponent. But first we'll subtract 3 from both sides of the equation. Okay, now this is going to be considered together here, which will help us with our next step. We need to get that exponent by itself, so we know it has to turn into a log. So we're going to rearrange this exponent statement into a logarithmic statement. The base is 2, so log base 2 of x subtract 3 equals what the exponent was, which is y subtract 1. Now add 1 to both sides of the equation. So plus 1 on the outside of the bracket there equals y. Turn it back into, change y to inverse notation, proper notation. And this then becomes our function. Okay, so that inverse function is this guy. Log base 2, x subtract 3 plus 1. Now, when we're talking about logarithmic function here and the transformations of that logarithmic function, we're going to compare it to the most simple log of that same base. So log base 2 of x. So compared to that function, we're going to have a horizontal translation, 3 units to the right, and a vertical translation, 1 unit up. Now again, notice the difference here. The vertical translation of the exponential became the horizontal translation of the logarithmic and vice versa. Okay, so just as one final note, when we're talking about these transformations, we're comparing it to y equals 2 to the power of x, which is its most simple base function. Okay. There we have it.